So all the stuff we did last time, you did in Algebra 2. This is the new thing that you haven't done last year, which is we're going to do the domain restrictions on the combined and composite functions. So you've done domain on functions before. Now you're going to do domain when you're like combining them together. So there's two main domain restrictions. And the first one is that you can't divide by 0. Those are the ones I call the troublemakers. Can't have a 0 denominator. So I'm going to do an example. We'll just make up an example here. So can you give me some single digit numbers? We'll just make something. All right. So we'll have 3 over x minus 4. So I made up that problem. Don't worry. I can ask for another number later. So who is your troublemaker in that one? Who is getting booted out of the domain? 4 is a problem. So your domain be negative infinity to 4 union 4 to infinity. So when you are leaving somebody out, like not including them, you will use a not equal to. Maybe put circles or stars next to that or something, because that ends up being the main question here is which symbol goes with which. That's you're leaving something out. It's your troublemakers. Everybody is invited except that one number. The other domain restriction, like prominent one, I mean, there's a lot of different things that can happen, but the two that we're going to basically look at is you cannot have a negative under an even root. So no negative under an even root. Then we're going to mainly deal with square roots, but I say even root because you can't have a negative under a 4th root or a 6th root or an 8th root. If the number's even, you can't have a negative under there. You can have negatives under the odd roots. Those don't have restrictions. So again, I'll make up an example and I'll put 8 in this one. And sorry, that's a subtraction. So if you have a square root, and I would think of it from like a graphing perspective, I'll just grab a sticky note and draw this for you. Let's review our transformations from back in unit 1. How did this shift? Up, down, left, right. Good. It went right 8. So just watch. 1, 2, 3, 4. Who picked 8? It would go right 8 and look like that. Following me there? So if you sweep left to right, your domain would be what to what? 8 to infinity. Would it get a bracket or a parenthesis? Bracket, because there's actually a number there. So it would be bracket 8 to infinity. You can't bracket in infinity. So when you do those ones, you're going from a number onwards. You're not just leaving somebody out. It's we're starting here and then above. So you will use a greater than or equal to with those ones. Because the big thing when we do this is which one of these symbols when we set up a problem are we going to use? So if you're just kicking out one number, it's a like the no parking sign, like not equal to. If it's your root, you want from that number and above. So it's a greater than or equal to. Cool so far? Okay. So whenever you have the combined function, and that's just when we added, subtracted, multiplied, or divided them, and we're going to just do adding them, you are just going to combine the two domains, which is fairly simple. You just put them together. All right, so we're going to find the domain of each of these and then just put them together. So if you were to graph this, what would it look like? Since there's a squared, quadrat, U shape, a parabola. Does that have any kind of restriction on it? No, it's everything. That domain would be all reals. A parabola goes forever both ways. Now, this one, I want you to think back what we did with here. It's just instead of an 8, it's a 5. 5 to, good, perfect. It went right 5, so it's bracket 5 to infinity. So if you think about putting those together, we're going to do the domain if you added the two functions. This one doesn't really matter. It's like anything goes. So really all you need is this one. So your final answer is just the 5 to infinity. If one of them's all reals, the answer is just going to be the other one. Because the one that's all reals doesn't really matter. You're sort of ignoring that because there wasn't any kind of restriction or rule about that. So you sort of just don't even worry about that. Let's try it again. What would be your domain for this? You're leaving out 9 is your troublemaker. So how would you write that? Yep, negative infinity to 9. Union 9 to infinity. It would need to be a parenthesis because you're trying to exclude it. You want to leave it out. If you put a bracket, you would be including it. Now, what would this one look like if you were to graph it? Linear. It's a line, right? So does it have any kind of restriction on it? No, it's all reals. A line goes forever both ways. So that one kind of doesn't matter. You're sort of just ignoring it. And so if you combine these, the answer is just going to be that you're leaving out 9. Again, if one of them is all reals, the answer is just the other one. You're trying to do both restrictions at the same time, but if one of them doesn't have a restriction, then it just doesn't matter. So again, if one of them's all reals, the answer is just the other one. Okay, now we're going to get into ones where they both have a restriction, so you can see what happens when we put them together. Who's your troublemaker on this one? -2. So we're going to leave out -2. Everyone is invited except -2. This one, compare back to what we did here, but instead of going right 8, what did this one do? It went left 5. So it would be bracket -5 to infinity because it went left instead of right. Does that make sense to everybody? Like it would look like this. Well, you can always think of it visually. So now they both had a restriction. So we want to do both of these at the same time. Think about your number line. You want to go -5 and above, but you also need to leave out -2. So when you combine them together, it will look like this. So you want -5 onwards, but you need to skip over -2. So you're doing both of them at the same time. So if one of them's all reals, you're kind of good. The answer is just the other one. If they both have some sort of restriction, you have to do both of them. You're just combining them. But this one says you have to stay -5 and above. So you have to stay -5 and above. And then this, it's like two people that both have rules. One of them is like, you have to stay -5 and above. So we needed to do that. And then this one was also like, but you also need to leave out -2. So you're trying to make both of them happy at the same time. Here, we'll try it again. Who's your troublemaker on this one? 6. So you would leave out 6. And then think about this one from a shifting perspective. Where did it shift? Which way? Went left 1. So it'll be bracket what? -1 onwards. So that person's saying, hey, you need to stay -1 and above. So we need that. But then we also need to leave out. So he's like, hey, you can't invite 6 either. So this guy is like, you have to stay -1 and above. But then this guy is like, but also don't invite 6 to the party. So it'll look like that. It's kind of like instead of starting with a negative infinity, you're starting with a -1 instead. Go ahead. Yes, and then to infinity. Reflections are a thing, but this topic is so complicated to start with, I don't ask those questions. So to answer you fully, yes, that could be possible, but I'm not going to do that to you. All right, so now we're going to get into the composite function domains. And I always draw a picture for these because I think a picture helps. So you're going to draw a circle. That is where all of the x's live. Those are all of your inputs. And we're going to plug them into function g. And what you get back out is g of x. I think some teachers, when they teach in Algebra 1, they call it a function machine. Did anyone's teacher teach it as a function machine? Or like you're smiling like you remember that. But yeah, it was a long time ago. Okay. So this would be the domain of G, and then this would be the range of G. That's what you did in Algebra 1. But now we're going to go a step further. Remember telephone game? Okay, I gave you a sentence, you changed it. So this is changing it. And then you take that new sentence and you passed it on to somebody else. So you're going to take that, plug it into function f, and what you get back out is a composite function, f of g of x. So this would be domain of f, and this would be range of f. So here's where this gets complicated. These two things need to make friends. And that involves setting up a math problem to solve. You end up solving a problem. Okay, is where these two are. Do you like my picture? How good on the picture? Like the little like leapfrog thing. All right, so to find the domain, there's two things. Number one, you check the inside function. If the inside function has a restriction, and by that, I mean, it's not all reals. There's some sort of restriction on it. The inside function has a restriction. Keep it. You are stuck with it. If the inside one isn't all reals, you keep that no matter what. So you check the inside one first. If that has a restriction, you're stuck with it. Good so far? Check the inside one. All right. And then second, this is where you set up a problem. That's this part. Your inside function must comply. And what do I mean by the word comply? Do we know what that word means? Agree or like follow the rules, like go along with, okay? Must comply with the domain of the outside function. And so again, that involves setting up a problem. So you set up a problem and you solve it. Remember the two symbols I brought up on the other side? One of them looks like the no parking sign, like the not equal to, and one of them's the greater than or equal to. That's where you're going to use one or the other of those symbols. And that's why I kind of stress that so hard, because the question I always get asked is, which symbol are you going to use? So let's look at the first two functions here. First, we're going to do the domains of just those. That's not new information. You've done that before. What would this look like if you graphed it? A U. So what's the domain? All reals. I'm not going to make you graph them. Just use your imagination. And then what would this one look like? A line. So its domain is all reals. I'm going to obviously start with the easiest problem. Now, before we even answer f of g and g of f, if both these domains are all reals, what do you think the domains of the composites are going to be? All reals. Okay, so this one's basically not even a problem. I just threw it on there to start with an easy one. But if you don't have any restrictions, I mean, that is important to understand. If you don't have any restrictions, then the composite's not going to have any restrictions either. So basically, we're just going to review what we did last class, which is good. All right, we need to review that. For this, which function gets plugged into which? Good. Don't write this on your paper because I'm going to have to erase it. G gets plugged into F. So this gets plugged in over here. I have some space underneath. Just like fill it in here. It'll be 3. And then instead of x squared, it would be x minus 5 squared. But you should probably just write it twice. That's what squared means. And then what comes after that is plus 4. And it's not hard. You just have to be able to multiply numbers together. Put the 3, start a parenthesis. What's that going to give us? You want to multiply all that stuff together. Get x squared minus 10x plus 25 plus 4 is like, hey, wait for me. And then I can put the answer on the line now. Like we'll get our final answer. Your last thing is to distribute the 3. So that would be 3x squared minus 30x. And then this would be plus what? 75, but then plus 4 more. So 79. Now I'm going to have to erase that. Now we're going to do it the other way. This time F gets plugged into G. This one's going to be a good bit easier. You're going to take this, plug it in over there. So it's just going to be this whole thing minus 5. this entire function minus 5. So what would that give us? It would be 3x squared, yeah, minus 1 plus 4 minus 5. So that was basically just a review of what we did last time. We didn't do anything with the domains because they were all reals. All right, this one won't be like that. So first, let's do the domains of just the functions. So what would x squared be? All reals? And then think about how this one shifted, like how we did these ones, just 4 instead of one of those other numbers. Yep, good. Yeah, good, perfect. So now, yes, and that's kind of what Adrian was asking too. Like, if I wanted to give you a reflection and make it go the other way, I could, but I don't because it's complicated enough. So the answer is it's possible. I'm just not going to do it. All right. So for this one, G gets plugged into F. So this gets plugged in over here. So you're going to have square root of x plus 4 squared. And the big question is, can you keep going or do you have to stop? Yes, good. You're going to keep going. The square root and the squared are going to cancel. And so you just get x plus 4. That's the hardest thing, is knowing when to like keep your hands off, right? But if it's not over the whole thing, then you can't cancel. All right, and then for the other one, we're going to take this and plug it in over here. So that would be square root of x squared plus 4. Now I went ahead and wrote that on the line because you can't do anything to that. Do you see how the squared is only on the x, but not the 4? It's only part of it. I know you're tired, but you're coming with me on that. All right, so now we're going to do the domains. So looking at this one, which one is the inside function? It's going to matter now. G is inside. Does G have a restriction? Do you see how it's not all reals? We're going to keep it. No matter what, you have to keep that. Okay, so hold that in your mind. Now we're going to do step 2. Does the outside function have a restriction? No. So there's no problem to set up because this one is cool. He's like anything, everyone's invited to the party. Okay, so we're just going to keep this restriction and that's our answer. And I'm going to say that again because I know like it needs repeated. G is the inside. Does G have a restriction? Yes. We're going to keep it. Did F have a restriction? No. So you don't need to set up a problem. This is just your answer. Now this one's backwards. Which one's the inside function now? F. Does F have a restriction? Great. Fantastic. Does G have a restriction? Okay, this is where you have to set up a problem. So when the outside function has some sort of rule. Hey, f of x, you better stay bigger than -4 or else no dessert. Do you get what I'm saying? He's like, you have to comply. Hey, f of x, which is x squared, we're going to set up a problem. X squared, you better stay bigger than -4 or else. So you set up a problem and it's going to be one of those two symbols and then you work it out and you just see what you get. You kind of just see where it takes you. What would you need to do to both sides here to try and like, yeah. Now, when you try to square root a negative, so yes, and we're not going to do imaginary numbers for domains. So what happens is you get something that is always true. And what I compare this to is when your parents come home and they're like, do your homework. And you're like, I already did it. Geez, it's done. Do you know what I mean? It's like, get off my back. I'm compliant already. X squared is always going to be bigger than -4. It's just always true. Why is that? And when you square something, it is positive. So it's going to be bigger than -4. It's just already compliant. And so your answer is all reals. Again, that's like your parents yelling at you to like get your chores done or whatever. And you're like, I already did it. Geez, get off my back. Already compliant. We'll do one more and then we'll do our break because I just want to like have it sink in before we stop here. All right, so do the domains of those by themselves. What is this one going to be? The square root. Yep, perfect. Bracket 9 to infinity. And then this one, all real numbers. It's squared, it's going to be everything. So for f of g, g gets plugged into f. So you're going to take this x squared and plug it in over here. So it'll be square root x squared minus 9. You can't simplify further, which is cool because there's no work. because the squared is only on the x, not the 9. That one I get all the time. People are like, isn't it x minus 3? No. Don't do anything. Don't try to make it more complicated. We cool? Hands off. All right. When you plug f into g, you're taking this and plugging it in over here. That's going to look like this. And so what's going to happen with that one? Yep, those cancel and you get x minus 9. Typically one works and one doesn't is the way that that happens. I'm going to actually do this one first because it's the easier one. Which one's the inside? F. Go to F first. Does F have a restriction? Keep it. Does G have a restriction? Great. You don't have to set up a problem. Your answer is just 9 to infinity. I did that one first because that was the easier one. All right, now let's do this one. Which one's the inside function? G. Does G have a restriction? Fantastic. G is very welcoming. Does F have a restriction? That's where you have to set up a problem. Hey, G of X, you better stay bigger than 9 or else. Can't go out with your friends tonight. G of X, you better stay bigger than 9 or else. So you're going to take G of X, which is X squared. You're just going to take the whole function and say, hey, you better stay bigger than 9. And then you just see where that takes you. The one we just did, it ended up being always true. It was like already compliant. This one's going to like not be that way. What would you do to both sides? You would square root. Now you can square root 9. And negative 3. It's plus and minus 3. Okay, so what you end up with, x is bigger than 3. And when you do the negative one, you have to flip the symbol. So smaller than negative 3. Here's what that's going to look like when you write it out. I'm going to write it and just shut my mouth and let you kind of have it sink in. I'm going to draw a picture of it for you because I really love how these look. And the visual helps a whole lot. If you draw that graph, it looks like it's like little alien antennas. Isn't that cute? That's cool, guys. It's neat. It's cool. Anyway, you want everything smaller than negative 3 and bigger than positive 3. It's the little alien antenna. Cool. That's what it would look like. That's a neat graph. That's cool. That a graph can look like that. It's neat. Neat. All right, so for number 8, who is your troublemaker for this one? Who are you leaving out? 0. Get rid of 0. 0 is causing problems. And then how about G of X? Yeah, it's going to be a line. So linear and quadratic are going to be always. All right, so for this one, G gets plugged into F. That means this X plus 3 gets plugged in for X over here. So what would that give us? Yeah, 1 over X plus 3. And then for this one, F gets plugged into G. So this 1 over X gets plugged in over here. So subtle difference, but that's going to give you 1 over X and then a plus 3. So it is a subtle difference. We did one like that last time. And I was like, hey, just bear in mind, we're going to do the domains next time. Now, for ones like these, what people typically do is just look at what they ended up with and decide who the troublemakers are. And I'm going to encourage you to do that because I think it's easier. All right. So when you look at this one, who's your troublemaker? Yeah, you've done that before. I think that's the easiest way to handle that. You would just be like, oh, negative 3 is the problem. Just leave out negative 3. That's easier than trying to set up an equation to solve. And then how about this one? It's 1 over X. The plus 3 really doesn't affect that though. So yeah, good. You would just leave out 0. So when you end up with rational ones like that, I would just look at the denominators. I think that's the easiest way to do it. I'm always going to try and explain it in what I feel is the easiest way, because if you start complicating things, that's where you make mistakes. All right, number 9. How about this one? Think about how it shifted. Oh, I messed up my sticky note, so I can't pull that back out. But in your imagination, think about how that shifted. What is your domain going to be? Yeah, it went right 1, so 1 to infinity. And then this one's quadratic. So everything, no problems. So G gets plugged into F. This whole thing gets plugged in over here. So you remove X, replace it with all of that. So it's going to be square root of all of that stuff, 1/4 X squared minus 1. I went ahead and wrote it on the line, so I kind of gave this away. You can't do anything else to that. The squared is only on the X, not the rest of it. So there's nothing else you can do to that. All right, and then for this one, F gets plugged into G. So this square root X minus 1 gets plugged in there. Now I'm going to work out a few steps on that. We will have to simplify that. So it'll be 1/4 and then this whole thing squared. So what is going to happen with that? Because we actually can go forward with that one. Good, those cancel, so it's 1/4, and I like how you said that, and then X minus 1, because there's actually one last step. You have to distribute, good. Oh my gosh, you guys make my life so easy, it's fantastic. So when you distribute, it'll be 1/4 X minus 1/4. 1/4 times 1 is just 1/4. All right, so let's do the domain for this one. Look where I'm pointing. Which one is the inside? G. Okay, does G have a restriction? Great. Fantastic. Does F have a restriction? That's where you have to set up a problem. And which one of these symbols are we going to use? The not equal to or the greater than or equal to? Good, because it's a root. So we're going to say, hey, G of X, you better stay bigger than 1. You better stay bigger than 1 or else no dessert. All right. So we're going to take G of X, this whole thing, 1/4 X squared, and say, hey, you better stay bigger than 1. And then you just try to work that out. Don't force it to be anything. You're just going to see what happens. What would you do to start solving? Times by 4. Good. That'll give you X squared is greater than or equal to 4. 1 times 4 is just 4. And then square root. So your square root of 4 is 2, and it's the little alien antennas. It's going to look like this. All right. So it would be negative infinity to what? -2. Good. Bracket union 2 to infinity. It's going to look like those little alien antennas. It's going to go like this. Those are cute. They're cute. All right. Which one is the inside one? F. Does F have a restriction? You are stuck with it. Keep it. Okay. Does G have a restriction? Great. That means you don't have to set up a problem. Your answer is just 1 to infinity. Do you see how taking a break and then coming back to it like makes it go better? It's like, you know, that's important for how your brain works. So you guys are doing excellent with this. You guys are doing awesome. All right. Who's your troublemaker? -3. Leave out -3. -3 is causing problems. Now, I haven't done an absolute value one yet. What shape is that? Like in your imagination, it's a V shape. So it's going to go both ways forever. So same as a quadratic, it's going to be all real. So just instead of a U, it's a V. Right? As a heads up, let me just say this. If there's an absolute value, you can't simplify anything, period. Like that, you will not be able to simplify anything. All right. You're just going to write the answer. So, oh, go ahead. Yeah, but I saved it for last because it's the hardest one. I get this all the time. Students tell me, it starts out so easy and then gets harder, Miss Cole. I plan the lessons that way. I start with the easy ones and then we work our way up to that. Like I design it that way. Okay. Yes, the last one they will both have a restriction. Okay. So here we're going to plug G into F. So this absolute value is getting plugged in over here. So it's going to be 1 over absolute value of that stuff plus 3. Don't do anything to that, please, for my sanity. Like you can't just do nothing. You can't put those together. One's inside and one's outside the absolute value. All right, here F gets plugged into G. So this 1 over X plus 3 gets plugged in over there. So it's going to be like an enormous absolute value with all of that stuff inside of it. But if there's an absolute value, you can't do anything. Just write it and move on. Hallelujah. All right. Which one are we looking at first here? G. Does G have a restriction? Great. Does F have a restriction? That's where you set up a problem. Hey, G of X, you better not what? You better not equal -3. I better not see you hanging out with -3. If you were hanging out with -3, we were going to have problems. Okay. G of X, you better not equal -3. So which one of those symbols are we using? Not equal to. Okay. So you're going to take G of X, that absolute value of X plus 2, and say, hey, you better not equal -3 or else. And then you kind of see where that takes you. But what do you think about that? An absolute value isn't going to be negative. By definition, it is positive. So that's the situation where it's like, geez, I'm already following the rules. Get off my back. Like, I'm already compliant. You get something that is always true. Good. So it's going to be everything. Like, you set up that problem, but it didn't take you anywhere. An absolute value is always going to be positive, so it can't equal -3. And again, that's like when your parents yell at you, like, hey, you better do your chores. I'm like, I already did it. Leave me alone. All right, now let's look at this one, which is inside. F. Does F have a restriction? Yes. What are you going to do? Keep it. Does G have a restriction? Hallelujah. That means you don't have to set up a problem. Your answer is just whatever the inside one was. So just copy it over. I'm going to try it again. I made this one very similar to that one, but it'll turn out different. All right, who's your troublemaker for F of X? 7. Kick out 7. 7 is a problem. We're almost done, ladies. All right, and then absolute value will be everything. So when you have an absolute value, there will not be any simplifying. Just write your answer, okay? F of G. G is going to get plugged in over here. So this whole absolute value gets plugged in for that X. It will look like this. All right, and then when you plug F into G, this fraction, this rational one, is going to get plugged in over here. So it's going to be absolute value of that whole thing. All right, so F of G, which one's inside? G. Does G have a restriction? No. Great. It's all reals. Does F have a restriction? Yeah, that's where you set up a problem. Hey, G of X, you better not what? You better not equal 7. Better not see you hanging out with 7. 7's a troublemaker. All right. So you're going to take G of X, this absolute value of X plus 4, and say, hey, you better not. Oh, which symbol do we use? Not equal to. You better not equal 7. The greater than or equal to is for the roots. Now that we're going to actually be able to work out. You do solve these in algebra too. I'll see like how well you remember this, but it splits and you get 2 problems. You do it early on in the year. So it was like a year ago. So you're going to have X plus 4 can't be 7, and you're going to have X plus 4 can't be -7. Some teachers teach it that they put the negative on the left side instead of the right side. So did your teacher, you know what, maybe your teacher did it this way. Okay, here, I'll try and do it the way your Algebra 2 teacher did it. Would they have put negative X minus 4 can't be 7? Okay. All right, so then we're going to work these out. What would you do to solve this one? -4. Okay, so X cannot be what number? 3, good. And then what would you do to start solving this one? You would +4, that'd be 11. Perfect. X cannot be 11. So you have 2 numbers getting kicked out. You have to kick out 3 and you have to kick out 11. How would we write that? I'll give you a hint. It starts with a negative infinity or question. Oh, yes, negative 11. I'm sorry. And that does change it. So I'm sorry. There, negative 11. So I'm sorry. We're going to kick out 3 and negative 11. So how would we write that? It's going to start with a negative infinity. Good. Okay, good. We have to do the smaller one first. Union 3. Union 3 to infinity. We did ones like that last unit where there were 2 troublemakers. You did that successfully. You were good at it. Now, can you humor me for 1 second just so I can show you this? Just humor me. Just look. If you try to plug in 3, because I get some people that do not want to do this work. They'll just guess and check until they figure out the 2 numbers. And that's a valid way to get through the problem. If you were like, hey, that was too much work, I'm just simply not doing it. Look, if you try to plug in 3 plus 4, absolute value of 7, 7 minus 7. If you, oh no, negative 11 plus 4, negative 7, absolute value that 7 minus 7. So I get some people that won't do this work. They'll just guess and check until they figure out the 2 numbers. And that's fine too. I don't care as long as your answer is right and you didn't cheat, right? So looking at this one, which is inside? F, does it have a restriction? Yeah, keep it. Does G have a restriction? Nope, that means this is your answer. It's when the outside function has a restriction that you have to set up a problem. You're going to be okay. All right. Think about how this shifted. Did it go left or right? Left. So it'll be bracket what? If it went left to negative 2 to infinity. Thank you. Thank you. All right. And then this one, who's your troublemaker? 6. Leave out 6. So do you see how they both have a restriction this time? All right. So for this one, G gets plugged into F. This 1 over x minus 6 gets plugged in over here. So it is going to be a gigantic square root. And then underneath of it, 1 over x minus 6 plus 2. There is not a thing you can do to that. Please leave it alone. Now, we're not going to do that domain. That gets needlessly complicated, and we're just not going to do that. Do you remember the rational graphs? When it got really complicated, I just left off those characteristics from the list. Like they just weren't there. Like I just wouldn't ask you it. Okay. Now here, F gets plugged into G. So this square root is getting plugged in over here. So it's going to be 1 over square root of x plus 2 minus 6. You can't combine those. The 2 is under the root, the 6 is not. It's the same thing with the absolute value. So just please do nothing. Like for the majority of these, you're going to do nothing. Okay. Which one is inside? F. Does F have a restriction? You are stuck with it, and that's what you need to keep in your head. Remember that. You have to stay bigger than negative 2. And G has a restriction. What is G's rule? You cannot, I better not see you hanging out with 6. 6 is a troublemaker. So you're going to take f of x, this entire thing, this square root of x plus 2, which symbol? I remembered to ask that time. Not equal to 6. And then you just solve that. You guys are good at solving. That will be the easy part. Setting it up and figuring that out is kind of hard, but you'll be fine from there. How do you get rid of a square root? Square. Bless you. So x plus 2 is not equal to, what is 6 squared? Yeah, see, you guys are good at that part. And then your last step, subtract 2. X cannot be 34. But remember, it also has to be bigger than negative 2. So you're going to go from negative 2 to where? 34 union 34 to infinity. So you have to stay bigger than negative 2 because that was the restriction on that one that you're stuck with. And you have to leave out 34.